The Boeing 777X has a wingspan wider than the A380, the biggest passenger plane ever built. It does it with half the engines. And that wing is so wide, it's technically illegal at almost every airport this plane was designed to serve. Boeing had to invent a mechanical trick just to be allowed to park it. Here are 5 reasons this thing shouldn't exist. Reason 1, a wing that breaks the rules of plane design. Most people assume a wider wing means a wider plane, a double-decker, a super jumbo. The 777X kills that idea with one number. A wingspan of 71.75 meters on a normal single-deck jet with only 2 engines. That's about 11 feet longer than the 777-300ER it replaces, and its wing area is bigger than its main rival, the Airbus A350-1000. Boeing says that gap is worth roughly 10% better fuel efficiency on similar routes. The reason it works is the material. The old 777 wing was aluminium. This one is carbon fiber borrowed from the Boeing 787 program. Carbon fiber let Boeing make the wing much longer and skinnier without the crushing weight metal would have added. And longer, skinnier wings make more lift with less drag. It's the same reason a glider's wing looks nothing like a fighter jet's. Here's the part nobody outside the industry thinks about. A wing that efficient is also incredibly bendy. In testing, Boeing pushed the wing to 1.5 times its rated load, and it flexed more than 26 feet upward before they stopped the test. Sit by the window in turbulence, and you'll watch that wingtip visibly rise and fall by several feet. It looks alarming. It's exactly what it was built to do. But the second this plane lands, that beautiful wing becomes a serious problem. Reason 2. It was too wide to legally park. Airports sort aircraft into strict wingspan categories. Anything over 65 meters falls into the top bracket, the same one as the A380 and the Boeing 747-8. Those gates are rare, expensive, and only found at a handful of major hubs. The 777X sits 6.75 meters over that line. Left alone, this plane could only land where super jumbos land, which would destroy the entire point of it as a practical 777 replacement. So Boeing built folding wingtips. Each tip is 3.5 meters long, driven by a hydraulic system, and folds upward on the ground. That drops the wingspan to 64.85 meters, sneaking it just inside the normal category every 777 and A350 already uses. The pilot triggers the fold with a single switch in the cockpit. The tips move in about 20 seconds, and a locking mechanism keeps them secure even through a total power failure. Folding wings aren't new. Navy fighter jets have folded theirs for decades to squeeze more aircraft onto a carrier deck. What's new is doing it on an airliner carrying 400 passengers where malfunction isn't an inconvenience. That meant a fully certified, redundant pilot-monitored system with its own cockpit alerts and emergency procedures. Boeing actually considered this exact idea back on the original 777 and rejected it as too complex and too risky to certify. What changed wasn't the mechanism, it was the maths. The efficiency from that extra 6.75 meters of wing finally outweighed the weight and complexity of folding it and composites, made the structure light enough for the trade to work. Reason 3, the engine that broke a world record by not chasing power. Every 777X flies with exactly one engine option, the GE9X. That alone is unusual because most wide-body programs let airlines choose between competing engine makers. Boeing went single source because this engine was built so specifically for this aircraft that competition was never really on the table. The GE9X is the largest commercial jet engine ever built with a fan around 134 inches across. That's wider than the entire fuselage of a Boeing 737. You could roll a whole narrow-body jet's body through the front of it. Now the twist. Despite being enormous, it's actually rated for less maximum thrust than the engine it replaces on the older 777-300ER. That sounds backwards for a new engine, until you understand the goal was never raw power, it was fuel burned per pound of thrust. GE built a bigger, slower spinning fan that pushes far more air around the engine core instead of through it. That's the single biggest lever for efficiency in a modern engine, and it's why this thing sips fuel compared to its ancestor. 3 manufacturing tricks made a fan that size possible. The blades are woven carbon fiber instead of titanium because titanium blades at that diameter would be dangerously heavy. The core uses ceramic composites that survive far hotter temperatures than metal, letting the engine run hotter and more efficiently without melting. And GE3D printed certain fuel nozzles as single pieces instead of assembling them from dozens of parts, cutting both weight and part count. Then comes the record. In testing, one GE9X produced 134,300 pounds of thrust. That's the highest thrust ever recorded from any jet engine in history, commercial or military. More than anything, bolted to a fighter jet. Picture roughly 10 fully loaded school buses held in the air by the force coming out of a single engine intake, the width of a small room. Reason 4. The cabin was rebuilt around your body. Everything so far has been about the machine. This one is about the people inside it. Cabin altitude is the air pressure your body actually feels at cruise. On older jets, it sits around 8,000 feet, like being on a mountain. On the 777X, it drops to roughly 6,000 feet. That keeps your blood oxygen higher for the entire flight, which is directly tied to stepping off feeling less destroyed. The cabin is also about 4 inches wider than the older 777, letting Boeing widen economy seats without shrinking the aisle. And it borrows the Boeing 787's humidity system, cutting the bone-dry air that causes a lot of that jet-lagged feeling. Noise is what passengers notice fastest. That big, slow spinning fan is much quieter than the engines it replaces, and Boeing says the aircraft's noise footprint is around 40% smaller than earlier 777s. That's the difference between reaching for headphones immediately and actually being able to hold a conversation at cruise. Pilots experience it differently too. They now manage the industry's first cockpit-controlled folding wingtip system, an entirely new item on the pre-departure checklist that didn't exist on any 777 before. And because the composite wing flexes so much, pilots describe the ride in turbulence as noticeably smoother, since the wing absorbs gusts like a diving board instead of slamming that shock into the cabin. Reason 5, the part almost nobody has ever seen. Here's the piece most people, including plenty of working pilots, have never laid eyes on. It's the inside of the folded wingtip. When the tip locks upward on the ground, it hides an interlocking hinge that looks almost like a woodworking finger joint, concealing rotary actuators, a power drive unit, and locking pins entirely inside the wing structure. It's engineered to be invisible. The only time anyone actually sees it exposed is during scheduled maintenance, because in flight and at the gate, it's always either fully folded or locked flush. That's deliberate. A mechanism passengers can't see is a mechanism they won't spend the whole flight worrying about. And none of this came cheap. Boeing built an entirely new factory wing at Everett just to bake these composite wings using a custom pressurized oven big enough to cure a wing section in one piece. Industry estimates put that investment in the billions before the program earned a cent. Compare that to Airbus, which simply capped the A350's wingspan to fit existing limits from the start, skipped folding wingtip development entirely, and got its plane into service years earlier. The 777X's road has been rough. It launched in 2013 targeting service around 2019. Cracks turned up on engine mount hardware during testing, pausing certification flights. First delivery to Lufthansa isn't expected until 2027, nearly 7 years late. And yet the order book held. More than 600 orders from Emirates, Qatar, Lufthansa, and others, with Boeing building airframes and engines ahead of certification, betting demand would survive the delay. Every generation of Boeing's long-haul fleet solved one problem. The original 777 solved range without 4 engines. The 300ER solved capacity. The Boeing 787 solved efficiency with composites. The 777X is trying to solve all 3 at once in one airframe without asking a single airport to change a single gate. That ambition is exactly why it's years late and billions over budget. It's the price of trying to out-engineer 3 problems simultaneously instead of picking one. Whether it becomes the defining wide body of the next 20 years, or the plane that proved you can push folding wing technology one step too far, is still an open question.